Good morning. I'm Bart Poulson, and I am here in my basement at my house in Salt Lake City, Utah. And here I am going to talk to you today about some of my personal themes or rules for doing data work that matters, that I think makes you and makes the people you work with and makes the community and the world a better place. And I say that because data work has power. It has significance and it has impact, and want to make sure that we're using our time and our resources and our influence well. Now, if you're joining me live, I'm going to invite you to make a comment and say hello and tell us where you are. I get the impression today is going to be an intimate group. Um if on the other hand you're joining us by video, this uh, recording is released immediately afterwards on LinkedIn, on YouTube, and hopefully, if things worked properly, on Facebook. And obviously, you can't comment there, but I'm glad to have you there with me um, when a time works for you. By the way, today I am wearing my I Am Knuff sweatshirt from the Barbie movie because I think it's on brand and it is consistent with the message I'm trying to communicate today about having a little more compassion for yourself and also having more compassion for the people that you work with and that you get data from and that you're communicating with. All of those things matter. So let me do the short version of my introduction here. Um, by the way, we have a user in Raleigh. Thanks so much for joining us. It's nice to have you here. Um, Let me jump right in with the conclusion, and I'm going to share a presentation here. My three rules for data work worth doing are: number one, solve real problems; number two, keep it simple; and number three, keep it kind. And I'm going to talk about each of these in turn. And so let me go through them one at a time, but I'm going to say, James Henry McKean, who was in my Psych 101 class at BYU, which meant it's over 22 years ago. But James, believe it or not, I remember you. And I'm so glad to have you here today. Thanks for coming. Um, let's take a look at these rules. Actually, no, back up. Before I get to the rules, let me give a little bit of background. So I have a sister, Lisa, who has a consulting or communications consulting company called Posey Corp. And on LinkedIn Learning, she has a newsletter called Innovate Communicate. And she's been on my office hours with me a couple of times because she has extraordinary experience and insight in how professionals can communicate effectively. Now, one of the things that she has mentioned many times is that communication involves repetition, it requires repetition, and that the rule of thumb is that the amount of repetition that is required for effective communication is about 10 times more than you think. And so you've got to say fewer things and say them more often. And not surprisingly, she's written about this more than once in her newsletter. Um, it's a beautiful short newsletter. I strongly encourage you to take a look at it. This is a URL that will take you to it on LinkedIn, bit.ly/LP for Lisa Poulson Innovate for Innovate Communicate. So bit.ly/LP-innovate. And one of the things that came to my mind when I was reading this, for again, about the fourth or fifth time, is I thought, well, what's my message? I've had taglines on my company before, and I've had things that I know I talk about. But what was funny is these three things I told you about immediately came to my mind in exactly that format: solve real problems, keep it simple, and keep it kind. And I see that as Data Lab's message and as my message in the 30 years of data work that I've been doing. the work that I do teaching at the university, the work I do teaching with LinkedIn Learning, and that I do teaching with my own company, datalab.cc, as well as my consulting work. So let me talk about each of these in a little more detail. Um, but first, I'm going to say hello from New York City, where I'm going to be in 2 weeks. My wife and I met in New York City. I went to the City University of New York Graduate Center. She was studying Alexander Technique right by Lincoln Center. And we're very excited to be coming back and visiting. And we have Errol from Jamaica. Thank you so much for coming. I'm actually kind of amazed. We've got people coming in. So thank you for being here. Let me talk to you about each of these principles. We'll go a little bit bigger. Principle number one, solve real problems. Now, I know that sounds obvious and I shouldn't have to point it out, but the fact is it's not obvious. What this means is first, know what the problem is that you're trying to solve. And believe it or not, even when a person has been commissioned for a project, it's not always clear exactly what they're supposed to find. Now, I'm not saying what are your conclusions supposed to be. I'm saying what is the question you're trying to answer. And the reason for that is a lot of times people give you the data set and say, tell me if there's anything interesting in there or model this outcome. That's great. But sometimes you need to know two things. Who is going to use the result and how are they going to use it? Because knowing your specific audience and knowing the things that they're able to do or they're not able to do is going to make a big difference. And so knowing what the problem is, what the question is. And part of that's important because it'll help you save a lot of work where you don't have to repeat and go back and forth in what you're doing. And you're not going to spend a lot of time answering the wrong question because you know what? I've done that in projects. I've spent a huge amount of time answering something and then realizing at the end, never mind, it's not the right thing. Um, and it's a little embarrassing to get to that situation, especially because you're a skilled person and you have these amazing skills and you want to use them effectively, but make sure you actually know what the problem is. So the first part of this one is knowing who is going to use the results and how are they going to use them, because telling them that they should implement some massive global machine learning algorithm when in fact that they're a 3-person nonprofit, that it's just they're not capable of it. And so, or knowing that you're advising human decision makers as opposed to some sort of uh, recommendation engine, that's going to be important too. Who is using it and how are they going to implement it? So know that. The second part of this problem, aside from knowing who and how, is are you solving a problem that should be solved? There are problems that you know are are best left ignored. Now, the problem is, if you're working with a company and they come to you and say, here's the issue." I have, I've got a couple of examples I talk about all the time. For me, one of the most significant was the researchers who a few years ago decided to produce a machine learning algorithm that could predict from a single profile photo whether a person was um, gay or lesbian, and I'm sure they thought it as an interesting research question, but my immediate question is, what are you doing that for? And did you ever consider what the consequences were of developing that particular piece of technology? You know, why are you doing that? Is this making anything better? The same thing can be true said about social media companies who work very hard to make their products more engaging. Now, engaging's fine, but I know that here in the United States, there are at least 20 different states that are suing social media companies for not being engaging, but for being outright addictive and for targeting minors in the process. And so you got to look at it and see, like, was that a problem that needs to be solved? Are we making things better? And again, I know the social media companies, they got a lot of power and influence. On the other hand, maybe they don't need to make something that's so engaging. Um, and I can think of others. I mean, it really makes me think about a lot of the assessment projects that I've been asked to provide data for, and you kind of go, why are you even assessing this? What are you hoping to accomplish? Um, and what are the consequences of this? When you're measuring something, when you're evaluating it, it tends to push things towards a kind of homogenization and standardization that maybe you don't want. And because the saying is what gets measured gets managed, and that gets reinforced. And so you want to be a little more careful about, is this project even worth doing? And I don't mean that in terms of a money sense. I mean, I realize that it's important to make a living, but there are other things you can do. I worked on a project once. I was an in-house consultant for a while, and one of the senior people came and said, I want to do a project that shows this result. They wanted to show that their organization was better in every way than the others. And we're just kind of going, whoa, whoa, whoa. You are starting with a conclusion, and you're simply asking us to provide little bullet points of fodder for your pregone, your foreordained conclusion. And so that was no good. I'm glad to say that we convinced them that that was not a good project, but instead a good project was to say, why are people interested in being involved in this organization or not? That's the real question, not I already know what I want to say and I just want you to provide me with factoids. That's not a good use of anybody's time. Let's go to the second point. So aside from solve real problems, oh, by the way, I also want to say that means actually provide solutions to them. Many analysts don't take their results all the way. They find a pattern, they'll find out that it's stable, that that it's valid. That's great. But what you need to do is go one more step. Excuse me. We'll see if that comes back. You need to give one more step and tell your client exactly what it is they need to do next. So you actually need to cross the line from being just an analyst to being a business consultant. This is what you do. You're actually telling them, if you do this, this will solve the problem. And so I've talked about this before. I've created a LinkedIn learning course on it, actionable insights for business data or business driven insights. And it's important to take that last final step to actually tell somebody, now here's what you do as a result of the analysis. So you're actually providing a concrete identifiable solution. Okay, next one, keep it simple. I have talked about this several times. It's a consistent theme in my newsletter. The data is for doing newsletter. And here's the deal. There are always more complicated ways to do things, and there are always simpler ways. And you know what? Complicated is never inherently better. Um, you may be familiar with the Netflix prize from, I don't know, 10 or 15 years ago, when Netflix um, was giving $1 million prize to anybody who could improve the accuracy or the utility of their recommendations by 10%. And they gave people a long time to do it. And it led to some astounding work in machine learning. And it was one of the first major examples of ensemble learning, because several different teams who were developing their own algorithms came together and combined their algorithms to come up with one high level algorithm that combined the results of each of them. It's called ensemble learning. And after an extraordinary amount of work, they were able to get past the 10%, and they won the $1 million. But interestingly, Netflix never implemented their strategy. And there's two reasons for this. Number one, it was a really complicated strategy. Again, it was several different machine learning algorithms, each of which was complex in its own right. And so it was a really difficult model. But the second one is Netflix changed their business model. They went from DVDs and Blu-rays discs in the mail to streaming. And it turns out that people's preferences and are dramatically different, because streaming is short term and requesting stuff in the mail is long term, and people request, Shakespeare long term, but they just want to watch another superhero movie right now. Um, Anyhow, I'm a big fan of keeping your statistical analyses and your machine learning models as simple as possible. For instance, I feel that every analysis should include just a straightforward linear regression as a baseline. And linear regression is really flexible, it's really easy to set up, and it's really easy to interpret. Um, and there are fancy versions. You can do logistic regression, and you can do um, multi-level or hierarchical models, and there are a lot of things that you can do, but just start with the simplest possible regression model. Use that as your baseline. See if other more complicated models bring something in that's better. Also, if you have sufficient quantity of data, um, a decision tree, not a random forest, just a decision tree, because a decision tree gives you a graph of the various ways. Cut, if yes, go here; if no, go here; if yes, go here; if no, go there. Decision trees are really easy to understand. And now a random forest, which is made up of many, many decision trees, is a very easy to set up, flexible, powerful method for analyzing data. A lot of people, at least once upon a time, use it as the go-to. Things have evolved since then. But a single decision tree is a great way of parsing the data for an initial first look and saying, can we come up with a model that works better than this? So I would recommend, whenever possible, well, a linear regression is basically always possible. And when it works, a decision tree, and use those and go on from there. The advantage of simple models is, first, they're easier to set up. They tend to have fewer complications. It takes less time to get them up and running. I mean, give me a data set, I could have a linear regression for you in 10 minutes. I mean, that includes like getting the data in and labeling things. Um, they're easier to set up, they take less time. Two, they're easier to interpret. Uh, a linear regression without interactions is one of the easiest things in the world to interpret. For every year of experience, add $55 of income, something like that. It's easy. Also, when things go wrong, it's easy to troubleshoot a linear regression. It's easy to troubleshoot, see what's going on in a decision tree. It's much more difficult to do the troubleshooting for a neural network because they're very, very sensitive to their hyperparameters. Um, Also, simple models tend to generalize better. One of the big risks in data work is overfitting. You develop a model that is too specifically oriented towards the training data that you gave it, and it doesn't generalize well, it doesn't perform as well when you take it to a new data set. Simpler models tend to generalize better. And so start with a simpler one. It generally will go out and be more effective in other circumstances. So I realize not every situation is going to be something that can be easily solved with a linear regression or a decision tree. There are going to be times that you genuinely need a neural network, that you need deep learning, that you need something more complicated than that. Um, but even then, start with a simple model to use it as a baseline for evaluating the marginal returns, the extra value brought in by the other approaches. It's going to make a difference. Um, I'll just mention one other thing. The simple models are relatively easy to learn. You can learn regression. I mean, I had my online data career started with a video I made about doing linear regression in SPSS. It was 9 minutes. I put it on YouTube, and I had people tell me that they learned more about statistics and regression in that 9-minute video than they did in a semester long class. Some things it's really easy to learn. It's easy to learn how to do regression. Other procedures like again, using neural networks or other um, really complicated themes, they're harder to learn. They take more time to get up and running, but a little bit of time gets you a long way in terms of getting set up with regression. Now let me bring it to my third point, which may seem like an odd one from a statistical point of view, but it's keep it kind. And this is where I'm going back to my shirt again from the Barbie movie, I Am Knuff, where Ken learns to accept himself and not engage in this possessive toxic masculinity, but learns that he's good how he is. He doesn't need to change things. This is a really important point for me. Keep it kind, and I mean kind in a few different ways. Number one, um be kind to yourself. You don't have to know how to do everything. um and you can do stuff, and even if you did it right, even if it was well intentioned and well guided, things crash and burn sometimes. That it happens. So be patient with yourself as you're doing your work. um Second, be kind to the people who have hired you, and that is, don't waste their time. Give them a presentation that's easy to understand. Give them an implementation that is easy to work with. Address it at the appropriate level for them. And sometimes that's just do more of this, do less of that, and we're good. Um, but the most important one for me right here is keeping it kind in terms of the people that you got the data from and the people who your results are going to impact. Um, this is going back to the first example of the AI gaydar. Why are you doing that? And you could cause a lot of um, you can cause a lot of drama for a lot of people by outing them on things that they're trying to keep private. Let people have their own lives. You're a marketing company, but you don't have to know everything about everybody. Let them have their space. Um, and you certainly don't want to develop an algorithm that's going to exacerbate some of the existing problems. Algorithms that are inherently extractive. Now, extractive is something that we think about like with oil or with mining, that you're going into the land and you're pulling something out, and then it's going to be of value to somebody else, usually who does not live on the land. In the data world, this extractive relationship means I'm gathering a whole bunch of data from the people who will never benefit from the results, and the benefit is going to go to people who already have a lot and might be more interested in exploiting this large group of people here. I gave a presentation once upon a time called Data Work Done Wrong. And I brought up the question, to do or to be done to. You know, wouldn't it be wonderful if we were in the business of empowering people who were not already in positions of power? Wouldn't it be great if we were in a position to give people more agency and more control over their own lives instead of giving other people more control over their lives? Data has this kind of power. Oh, you know what? I'll just mention, since James brought this up, the target algorithm. Yeah, I remember that one. Um, and the story is that Target had developed a market here in the United States. That Target had developed an algorithm that could predict whether customers were likely to be pregnant, so they could start sending them, coupons for diapers and formula and other things like that. And the story goes that a father intercepted a letter addressed to his teenage daughter and found out that she was pregnant, and then he went and confronted them and said, how dare you, why are you sending this stuff to my daughter? And then anyhow, it turned out that she was pregnant. I cannot remember if that story is literally true. It might be, it might not be, but it certainly gives the idea of people knowing a lot of things about you. Um, Privacy is important. You may be aware that the large companies get fined billions and billions of dollars for violating privacy practices, and for having monopolies. I mean, it's going on all the time. I have a list of cases that are going on. Um, and it also gets back to, social media developing algorithms that are specifically addictive. What? You don't need to have people on their phones all the time. And so thinking about the well-being of the people that you're actually going to, oh my goodness. James says, worked with the person who built the algorithm. Oh my goodness. Okay. Verification. Thank you so much for setting me straight on that one. Oh my goodness. It's horrifying. Yeah. Wow. Geez Louise. I love working with data, but I rode my bike for 3 hours yesterday. I do my most recent LinkedIn newsletter was, that you don't need to optimize everything. Give yourself a little space. And so when I say keep it kind, part of that is giving yourself space and giving the people from whom you get the data, give them some space to have their privacy, to live their own lives, to make their own decisions without you trying to influence everything or the people for whom you're making the analyses, the algorithms. Anyhow, um, I will just say, let's go back to my first slide here. Here's my 3 rules. Solve real problems. So actually know what problem you're solving and make sure it's something that's worth solving. 2, keep it simple. Start with simple methods. They work a lot better in so many ways. Only get it more advanced if it actually works and helps and makes things better. And then 3, keep it kind. Be kind to yourself, be kind to the people that you're working for, be respectful of their time, but especially be kind and thoughtful and empathetic for the people who both provided the data and whose lives will be impacted by the results of your analysis. Anyhow, that's my message. Those are principles that I use in doing my own work. At the university, I teach statistics in what used to be the behavioral science department. Now it's psychology and counseling. So most of my people are planning on becoming psychologists or therapists of one kind or another. And they're also going to be small business owners. And so I try to make it so that the way that I teach statistics, which I'm in the process of redoing. It's a massive project to recreate the entire course. Um, that it addresses these principles, that we know what the problem is, we solve real problems, that we keep it simple, and that we keep it kind as we go through. And my hope is that when each of us are engaging in our data work, we will keep these principles in mind, and then we'll actually show a little more of the beneficial impact of working with data. And with that, um, please remember, those of you who are here with me live today, thank you very much for joining me. And this is also being recorded and will be available immediately after on LinkedIn, on YouTube, and on Facebook. And with that, thank you so much for joining me. And especially James, thank you for giving me the foundational truth on one of the best known stories in data science. Folks, thanks so much for coming. I hope to see you again. Bye-bye.